Okay, I'm with the Nature Conservancy of West Virginia. Can you hear me? Okay. My name is Ruth Thornton. I'm the Conservation Information Manager there. And we don't really provide a lot of or produce a lot of data sets, at least in West Virginia, mainly just the TNC preserves that we have. I usually just try to find data and bug people about getting their data. So I've talked to a number of you about data sets that we can use for us to find high quality natural areas that we can prioritize for restoration and protection projects. And what I'd like to talk about is one of my main projects that I've been working on, which is the West Virginia Watershed Assessment Pilot Project. And I also have a poster about this in the poster section. And basically the project objectives for this were to design and test a watershed assessment process that can then be replicated throughout West Virginia's remaining watersheds. So for right now, we're working in 5 different pocket watersheds throughout the state. And then hopefully, what we're trying to do now is develop the methodology, excuse me, that then can be reproduced in other watersheds. And basically, I'm trying to find data sets and develop methods to help us assess the condition of these watersheds. Another very important part of this project is to identify data gaps and data needs that we have. So if there are particular data sets that we are missing, that we know would really help us assess the quality of these watersheds, then that is something that we're going to try to find and talk to different agencies about developing those data sets so that in the future they will be available for other watershed assessments. So for this project, we're working in 5 different watersheds. This is a 2-year project. We're about halfway through right now. We're just over the 1-year mark for these. And we have worked so far in the Mon and the Elk watersheds. And we're just about done with those. We're in the process of wrapping up the reports. And next year, this year, we're going to start expanding our assessment to 3 additional watersheds, the Gauley, the Little Kanawha, and the Upper Guyandotte. And so with these additional data sets, and hopefully be able to refine our methodology and really get at those metrics that will help us define the quality of these watersheds. So what we did, so just for an example, these are the upper and the lower Mon Pocket 8 watersheds in West Virginia, and we divided them into different planning units. The first set of planning units is the Huck 12 watersheds, and this is something that is very important, for example, for regulatory agencies, and they specifically requested that we focus on Huck 12 watersheds at least as one of our set of planning units, because that's what they're working on. That's the spatial level basically that they're working on. Then we defined another set of planning units, the catchments, and these are based on NHP plus catchments, and we've modified them a little bit to make them a little bit more consistent in size. So we basically have most of our catchment planning units ranging in size from about 100 to 500 acres. A few of them are smaller, a few of them are a little bit bigger than that. We also divided the watersheds into 3 different landscape types that make up a watershed. The stream riparian areas, which are defined as the stream itself, and then a data set that the Eastern Resource Office of the Nature Conservancy has developed, which is called the active river area, which defines a buffer along those streams that is between 90 and 125 meters and usually includes the floodplain wetlands in those areas. So that's what we define as our stream or riparian areas. And then we also defined wetlands, which is basically the wetland itself and a 50-meter buffer. And for particular metrics, we also calculated them based on not necessarily the wetland buffer, but the catchment area, so the drainage area leading up to a particular wetland. And then the uplands was basically anything else. And we thought it was really important to focus on the uplands as one of our landscape types, because that is something that is actually usually or very often neglected in a lot of watershed assessment. But the uplands are such an integral part of the watershed, we felt it really needed to have its own landscape type defined. So what we came up with was basically a hierarchical structure for our models, where we have the 3 different models, the streams, the wetlands, and uplands, and then we defined metrics and data sets based on 2 categories, the condition and the function of each model, And then also what we call a consolidated analysis, where we're looking at potential future threats, so potential future energy development, climate change, population changes, things like that that might affect the watersheds, and how to prioritize areas within them. And then we define several indices per category and multiple metrics that define each index. So just to show you, give you a quick overview of each model here. We have the model up here, the Screen's-Riparian model in this case, and we're looking we're looking to define the condition or the function of this. And in the top row here are the indices. And for the Screens, we define water quality, water quantity, hydrologic connectivity, biodiversity, riparian habitat, and protected lands. And each of these indices then have a number of different metrics. We started out with 230 metrics for this entire assessment. So we were really trying to gather all sorts of information that we could find from different agencies within the state that would help us define the quality and prioritize areas within these areas. Now obviously 230 metrics is kind of an unmanageable number, especially after trying to expand this to other watersheds. So what we're hoping to do is hone these down and through correlation analyses and through additional regression analyses over the next year as we're getting more data sets from these 3 additional watersheds to really get it down to those metrics that will help us define the quality of each of these indices and really get down to, which metrics, which data sets do we need that will tell us the story of where do we need to work within these watersheds. So basically what we're doing is we're finding a score for each of the metrics, which are then averaged to get a score for each index. And we think that the most useful part of these models are going to be actually the index scores, where we have a score for water quality, for water quantity, for riparian habitat, and these scores will help people find areas that they might be interested in protecting or restoring, whatever their particular goal or their particular mission is of different groups that are working in these watersheds. And this shows a consolidated analysis, so the future threats assessment, which has kind of a similar structure as these condition function models, where we have our future threats and priority interest areas, so areas where other partners might be working in these watersheds already, that might be their priorities. And then sub-indices for energy, population development, climate change, and projected land use. So trying to really define, to quantify in some way the future threats on these. Now this really didn't have very good or very detailed data sets available, so we only did this on a HUC 12 level, not the catchment level, because those projections are so broad, and for example, population development projections are very hard to find for most of West Virginia. For the 2 watersheds that we worked on so far, we really only found good data for Morgantown, not really for the Charleston area, and the areas outside of those metropolitan areas really didn't have much data available for them. So if any of you might have data that would help us, inform some of these, I'd be really grateful to hear from you, so that we can define our future threats assessment a little bit better. Our project outputs are basically the 5 watershed assessment reports, which I think is pretty standard for most watershed assessments. But then also, what I think will be the most useful aspect of this tool is to have an interactive web mapping application. This will be housed on the DEP website. We are working with the DEP. We got funded by the EPA, and we got funding through them. And basically, this will allow all sorts of different users, watershed associations, private individuals, agency personnel to use this, to go to this website, to not only see the results of our assessments and of our prioritization and our analyses, but then also to look beyond those at the underlying data sets that we assembled and brought together for this one project. And we've had some workshops where we've worked with different experts and we've introduced this project to different potential user groups, and they've actually told us that this is, they see this as one of our most useful products out of this project, is just to get all these data sets that almost all of them are publicly available, but put them in one spot so that people can really see them all at the same time instead of having to go digging through all these different websites from different agencies. So basically the interactive web mapping application is going to be this tool where People can look at the different data sets, not only our analysis, but really what drove them, look at the attribute information, figure out why a certain area got a certain ranking, develop customized scenarios to rank target areas for a particular group's mission or goals, and then possibly to manipulate the weighting of different factors. And we haven't really decided if we want to go that far in allowing users to go that detailed into their own scenarios. We've had lots of buy-in from different partners for this project. Federal and state agencies. We've had Cloud Unlimited, West Virginia University help us out with some of these questions. Maine Valley Institute helped us, different private groups, watershed associations. So it's really been great to have so much buy-in and a lot of help and constructive criticism from different agencies on how to build this project. And that's it in a nutshell.